All right, so this is the day you guys have all been waiting for, where we're going to talk about the shortcut for finding the derivative of polynomial or polynomial type functions. So the first part of this says to consider the function f of x equals 3. What does this graph look like? So f of x equals 3 is going to be a horizontal line where y equals 3. Right? If a tangent line were drawn to f of x anywhere at x, what would the slope of that line be? So basically the slope of a horizontal line is going to be 0. And that would be the case for any horizontal line or any f of x equals a constant. So if we have the derivative of a constant, that's just going to be 0. So f prime of x, if f of x is c, is always going to be 0. Okay, so I'm going to go through these next 6 problems and just do the derivative in my head and see if you can figure out what I'm doing. So if you haven't figured it out yet, just pause it. You can pause it, write it all down, and see if you can figure it out. All right, so what you do, if it's a polynomial type or a polynomial function, you want to find the derivative. You take the exponent, multiply it by the coefficient, that's your new coefficient, and then you take 1 away from the exponent. And then anytime that you have a term that's a constant term, it just drops off because the derivative of a constant is 0. All right, so that's our formula. That's our shortcut. So d over dx means the derivative of x to the n. You're going to multiply by that n, and then you're going to take 1 away from it, and that's your new exponent. Okay. Now, if you have a sum or difference of polynomial terms, then what you do, so if you have the derivative of 2 functions added to each other, it's just you find each derivative and add them together. And then same thing for subtraction. Okay, so let's do some examples. Oh, wait, hold on, we have a couple other things. So in order to apply the power rule for differentiation, that's what that rule is that we wrote here. This is the power rule. The equation must be written in polynomial form. So what do you think polynomial form refers to? And that's going to be the sum or difference of multiple monomials. Right, so for example, f of x equals a x to the n plus b x to the n minus 1 plus all the way down to a constant. Now that's an official polynomial, but we're going to have some where you have negative exponents. That's okay. We're going to have fractional exponents. And we can still use polynomial rules when it isn't exactly a polynomial. But on one like this first example, where we have this x in the denominator, we can't use the shortcut power rule for that one because the x is in the denominator, but we can rewrite the function. So 2 over x squared is the same as 2x to the negative 2. And then we leave minus 4x cubed. Okay, so sometimes on these, you're going to have to first rewrite it in another way. Then we can find the derivative by using the power rule. So we would multiply negative 2 times 2, and then take 1 away from negative 2, which would be negative 3. Multiply 3 times negative 4, and then take 1 away. Now, the directions say to leave your answers with no negative or rational exponents, and as a single rational function when applicable. So this should also be written like if we don't want a negative exponent, we would write it as negative 4 over x cubed minus 12x squared. Right, and most of the time that's fine. But because the directions are the way they are, they want us to bring that together as one fraction. So this is like over 1, so our common denominator is going to be x cubed. That one would need to be multiplied by an x cubed on top and bottom. So it's going to be negative 4 minus 12x to the 5th. Okay, let's look at the next one. Now we need to do some simplifying first. So what we can do on this one is just divide each of these by x and reduce it down. All right, and then be careful with your notation. So we did f prime of x in the last one. We can do y prime. I'm going to write this as dy over dx. I like that notation. And then we're going to multiply and take 1 away. We multiply 1 times 3, it's going to be negative 3. Take an x away, that's going to be no x's. This is our derivative. When we're done, we don't have any negative exponents or any fractional exponents. All right, on this first one, the next one, we are going to have to do some multiplying out. So I'm just going to multiply the first pair together. And then multiply that by the second one. So we're going to distribute the 2x. And then multiply by the 1. All right, this is still g. Just simplifying it down. Okay, so now we're ready to go ahead and find the derivative by multiplying by the exponent and subtracting 1 to get our new exponent. And once we get down to the 6th, because it's a constant, the derivative is 0, so it just drops off. All right, next one is similar to the one above it. The difference is the denominator's power is less, so we are going to subtract 3 minus 5, and that's going to be x to the negative 2. And then subtract 2 minus 5, so it's minus 5x to the negative 3. All right, and we're ready to find the derivative by multiplying and taking away 1, and then multiplying and taking away 1. And then I'm going to reduce it down. So this is really negative 2 over x cubed plus 15 over x to the fourth. Your LCD is going to be x to the fourth. So this one needs another x. We'll have x to the fourth in denominator. Numerator is going to be negative 2x plus 15. Alright. This next one is going to make you remember more algebra, which is what exponent means to square and then take the cube root. And that exponent is raising it to the 2/3. And then because that's in the denominator, let's just go ahead and subtract. Sorry, I wasn't thinking right. So this is going to be 1 minus 2/3, so it's 3x to the 1/3. Okay, and then I'm going to find the derivative, so I'm going to call it dy dx. I'm going to make sure I'm looking at this one. And I'm going to multiply 1/3 times 3 is 1, subtract 1 from 1/3, it's going to be negative 2/3. Alright, now this has a couple of things that the directions say not to have. It has a negative exponent and it has a fractional exponent. So that means I'm going to move it down to the denominator and it becomes a positive, but it's still a fraction, so it's the cube root of x squared. Okay. Alright, so this one's ready. We don't have any simplifying to do to get it in the right form. We can go ahead and multiply. So 3/4 times negative 4 is negative 3. Subtract 1 from 3/4, it's negative 1/4. Right, multiply 1/4 times 2 is 1/2. And subtract, we're going to get negative 3/4. All right, this one's a little challenging to get it in the right form. All right, so we have negative 3 over x to the 1/4 plus 1 over 2x to the 3/4. All right, so 2x to the 3/4 is going to be our common denominator. So I know I'm going to have to multiply by 2. And then think about, like, what would I add to 1/4 to make it 3/4? That's going to be 2/4. Or 1/2, really. Okay, so I'm ready to make my 1 denominator with 2x to the 3/4 in the denominator because it's my common denominator. And then that's going to be negative 6. And then, like I said a second ago, 2/4 is 1/2. And again, the directions say not to leave any negative or rational exponents. So negative 6x to the 1/2 is negative 6 squared of x. And then 2x to the 3/4 is 2, and then the 4th root of x cubed. Boom. Okay, so today is one of those days I feel like the calculus is easier than the algebra you have to do to get it in the right form. So for your assignment on page 114, I want you to do 4 through 18 even, 26, 30, 34, 42, 46, 50.